experiment number 9, which is about measurement of capacitive and inductive reactances. So we have here this circuit, number 1, and this is another circuit with different capacitance connected to the same resistance, and we will measure the capacitive reactance of this circuit and this circuit. And we have this table to measure the voltage across the resistance, the current in this circuit, and the voltage across the capacitance, and the capacitive reactance, and the capacitance of the capacitive reactance, one for C1 and one for C2. So we have here C1 and C2. We have this capacitance 932, and this capacitance 919, and this 1 kilo ohm resistance. So to measure the capacitance, change this one to 0.01 microfarad, I think so. I will measure it using the DMM. So I will put this one on the capacitance here and measure the capacitance of this capacitor. And it gives me 102 nanofarad, which is 0.1 microfarad. Micro means 10 to the power minus 6. Now to measure the other capacitance. It's 10 nanofarad, means 0.01 microfarad. So now I will connect the first circuit. 3 volts RMS, 1 kilohertz with the 0.1 microfarad and series with 1 kilo ohm resistance. So here is my function generator. I put on the frequency. This is the frequency. I put 1000. I click on hertz. This is 1000 hertz. I go to the RMS, change the voltage to RMS, click on amplitude and make it 3 volts. Now check the measurement using the DMM. I connected the DMM with the function generator so I can measures the voltage RMS and the frequency. So I set here voltage and the frequency. So the frequency is 1000. And the amplitude voltage converted to RMS and make it also 3 volts. Now let's see the voltage here. The voltage here is 2.9, so I will adjust from here the voltage. Here it's 3 RMS. You can see the frequency using this button. It's 1 kilohertz, 3 volt RMS. So now it's okay. So I will connect this to this circuit. What I did here is I connected the negative here and the positive here, like this circuit. The negative is on the resistance and the positive on the terminal of the capacitance. Now I need to connect an ammeter between the capacitance and the resistance to measure the current that is flowing through the circuit. So I connected the terminal of the ammeter here to measure the current. So I will put AC since it's AC circuit. So here I will get the AC current. It is 1.65 milliamp. So the current here is 1.65 milliampere. The voltage across the resistance, I will set this one to an AC voltage, and I will measure the voltage across the resistance. So I will connect it here. So the voltage is 1.6 volt AC. So I will write here 1.6 volt. Now the voltage across the capacitance, I will take the terminal of the DMM, put it across the capacitance. So I will get 2.52 volts. 2.52 volts. Here the capacitive reactance XC will equal to the voltage, which is 2.52 volts divided by 1.65 times 10 to the power minus 3, and that will give me the milliamp, the kilo ohm resistance of the capacitive reactance. So the results will be something in kilo ohm. Next, C will equal to 1 over 2 pi times the frequency, which is 1000, times whatever the value of XC is here. Put it right here, times 10 to the power 3, since it's in kilo ohm. So there will be a number here. Next step is to remove this capacitance and use the other one, which is this one, which is the 0.01 microfarad, and do the same thing again here, and then you can compare the two results. The other thing is to connect two capacitances in series, and then to connect them in parallel. To connect them in series, what I will do is I will connect this end to this end, and then I will connect this capacitance with the resistance, so I will get this circuit in series. Now we have the supply. I will connect the negative here and the positive on the other side here. So here I have the same circuit in series. And the same thing, if I want to measure the current, I will connect the positive of the source to this end of the ammeter, and then the negative I will connect it here. So here I can measure the current that is flowing through this circuit, which is 0.07 milliamp. Now I will connect them, and then also I can measure the voltage here, the voltage here, and the voltage across the resistance. Connect them in parallel. What I will do, I have this capacitance in parallel with this capacitance. So what I will do is I will connect this end with this end, and this terminal with this terminal, so I have them in parallel. and then not to connect this one here, but rather to connect this one to the source. So this source should be connected here, but since I want to measure the current, I will connect the black wire of the ammeter here, and then this one will be connected to the positive of the ammeter. So now I have this circuit, and I can see the current here, 1.6 for example. And then I can also measure the voltage here, the voltage here, and the voltage here, and I can measure the capacitive reactance. The same thing goes for the inductance. It's the same as the capacitance. We will have two in series and two in parallel, and we can do the same measurement.